By popular demand, I will cover Page Object Model. Page Object Model is a design pattern that's used as a component in our automation framework. I'm going to show you how to create a Page Object Model step by step from scratch. Right now, I release videos 3 times a week on Monday, Wednesday, and Friday. In the future, I plan to start releasing videos 5 times a week. If you're interested, subscribe to my YouTube channel, click the bell icon. You can also connect with me on LinkedIn, Twitter, and Facebook. After this video, I'm going to place the transcript and the presentation on GitHub. Page Object Model allows us to represent the behavior of our application and only update our code in one place. In this introduction, I will speak about what is a Page Object Model, why Page Object Models are important, and the benefits of a Page Object Model. After the intro, I will demo how to create a Page Object Model. Then we are going to create our first test using the Page Object Model. Introduction. What is a Page Object Model? A Page Object Model is a popular design pattern with classes that represent each page of an application. In some cases, it will be the entire page, and other cases, it will be part of a page. The purpose of a Page Object Model is to serve as a pattern for the application we are testing. Our elements and interactions are stored separate from the test script. Each web page or section of a web page is represented by a page object. In this example, we see the web pages or login page and home page. Both pages have their own page object called login page and home page. The page object is a class, and within that class, we have class members. We see the class members are variables and methods. Variables are defined as elements of the page, while methods are implemented as interactions with those elements. The test scripts reuse a page object when it needs to interact with a particular page. Everything starts by creating a base and the correct page object. Here's the catch. There's more than one way for designing our Page Object Model. So people will do things a little different. Why is the Page Object Model important? The Page Object Model is important because it helps with the DRY principle. DRY stands for Don't Repeat Yourself. This principle provides support to us by not repeating the same code. We store each field and method in an object repository. The object repository is designed to help reduce overhead for our test by storing properties and actions in one location. If your test, and you notice that you're writing your test and you have the same code over and over, then that code is a candidate for the DRY principle. The DRY principle falls under the OOPS concept, which is an acronym for Object-Oriented Programming. Object-Oriented Programming is a foundation for Page Object Model. We have the opportunity to use all 4 OOPS concepts with Page Object Model. The 4 OOPS concepts are encapsulation, inheritance, polymorphism, and abstraction. For example, encapsulation hides the details from our test script. Inheritance allows us to extend a class, and polymorphism can be used to override a method. And abstraction prevents us from creating an object from the abstract class. If you want to, you can brush up on your knowledge of the OOPS concepts by watching my playlist, which include videos 108 through 121. The benefits of a Page Object Model includes code reusability and code readability and code maintainability. Let me say that again because I kind of messed up. The benefits of a Page Object Model is code reusability and code maintainability. Plus, it includes code maintainability. Code reusability is when we reuse code in multiple locations in our program. That prevents us from rewriting the same code. Code readability means the code is easy to follow. It's easy to follow because the names are descriptive and there are less lines of code. Code maintainability means it will take less time to make a change to our code. Therefore, we can expect to revisit the code again in the future. That's it for Introduction to Page Object Model. Next, I'm going to show you how I create a page object model, and I'll see you in the next video. When creating a page object model, I prefer to start with the base page. The purpose of a base page is to have a class with common actions that can be used across different page objects. Recall from the introduction, a page object is a class with variables and methods. The variables define elements of the page, while methods are implemented as interactions with those elements. In this video, I will demo step by step how to create a base page and how to create two page objects. The page objects will be login page and products page. My plan is to explain each concept and not just show you the concepts. If you're interested in more videos, you can subscribe to my YouTube channel and click the bell icon. You can also follow me on Twitter, connect with me on LinkedIn and Facebook. After this video, I will create a transcript and place the transcript and code on GitHub. Here's the layout of our page object model. We have two folders, one for pages and one for tests. The base page and page objects are placed in the com.saucedemo.pages folder. Then I place the base test and test scripts in the com.saucedemo.test folder. The URL of our application is saucedemo.com. Let's start the page object model with an abstraction page, base page class. Public abstract class base page. Abstract classes cannot be instantiated. Therefore, I am making the base page abstract so an object is not created from this class. With inheritance, the role of this base page is to operate as a parent class, and each page class operates as the child class. Since the base page is a parent class, it should contain class members that's also available on other pages in our application. Some variables that's available on other pages are page URL, page title, and an object that waits for an element. When it comes to the driver, protected, web driver, we can take more than one approach, at least 3 approaches. One approach we can take is inheriting WebDriver throughout all of our page classes, from the beginning of our page class to the end of our page class. Then instantiate the object in our base test. The second approach is to declare WebDriver as public static and make sure the driver always retains the last reference. Then add an if statement to check if the driver is null. The first 2 approaches is better for the drop principle. However, in this session, I am going with a different approach and create a constructor, then pass in WebDriver as an argument. Public base page. WebDriver driver. This dot driver equals driver. The driver will be used to access the browser and locate elements. Find element is the Selenium method we use to locate elements. So let's write protected web element find by locator. Return driver.findElement locator. This will be the only place in my page object model that you will see driver.findElement. I will never write it again. We can reuse this find method in our base page and all of our page classes. Type in data and clicking an element or more generic methods that is common to all pages in our class. So let's write protected void type string text by locator. We pass in string for the data our test script will type. The by locator is a parameter for locating an element. Look how the previous method reduces code duplication. I would not rewrite driver.findElement, but only write find locator dot clear. If there is data in a field, then clear the data and write find locator dot send keys text. That's smooth, and that's all we write to type data. I will use the same process for the next method. The next method is protected void click by locator. Find locator dot click. That's all we need to click an element. This same click method will click a button, click a link, and click any other elements that can be clicked on the web page. Let's write one more method. How about we check if an element is displayed? Protected Boolean is displayed by locator. Return find locator dot is displayed. Know what? Let's wrap this return statement in a try catch block. Try and paste the statement. Catch no such element exception exe and return false. If an element is not on a page, then our code will catch the no such element exception and return false. I added Boolean as the return type because if displayed returns true or false. These other two methods have void as the return type because they do not return a value. The find method has a web element as the return type because find element returns a web element. The objective of this base page is to allow all of the page classes to inherit the base variables and methods. Next is the login page. For convention, it is best to have a class name that represents a page in our application. That's why I have login page as the class name. In the application, we have some elements on the login page. A username field, password field, login button, and error message. Our page class will have properties. We can also say fields to represent these four elements. The login page extends our base page, And thanks to inheritance, we see the methods created in the base page. Is displayed, click, type, and find. Those four methods will perform actions on the private by username field, private by password field, private by login button, and private by error message. With encapsulation, the fields are private, so only methods in this login page class have access to the fields. Remember, by is a class for locating elements, and the values are going to be locators for each element. Let's go back to the application and get their values. Right-click, inspect username. We see the form tag has username, password, and login button. All of the elements have an ID attribute. Username has a value of user-name. Okay, cool. Password has a value of password. The login button has a value of login-button. Inspect the error message. And it does not contain an ID attribute, but the closest ID is located in the parent tag. Let's use CSS selector for the error message. Control F and write hashtag login underscore button underscore container space H3. Bingo. 1 of 1. Copy the value. You can watch my playlist, Customize XPath and CSS values, if you would like to see how I created this value. The value for username is equals by dot, and we see the Selenium locators. Class name, CSS selector, ID, link text, name, partial link text, tag name, and XPath. We're going to use ID, double quotes, user hyphen name. Password equals by dot ID, double quotes, password. Login button, by dot ID, double quotes, login hyphen button. Error message is by dot CSS selector. Paste the value. The constructor is public login page web driver super driver. We are calling super, then passing in the driver to load the constructor from our base page. The constructor is created to bring in the web driver so the driver can access the browser. We have our constructor and fields. Now let's work on the methods, which will perform actions on these fields. There are 4 types of methods we can use in our page object model. We can have getter and setter methods that comes with encapsulation. Also, we have transition methods and convenience methods. The convenience methods can also be called helper methods. The getter methods get the states of our application, and setter methods helps us to create a test that interacts with our application. A transition method is important when our application changes to a different page. It may change when we click a button or click a link. A convenience method is created when combining more than one method into a single method. I'm going to demo all 4. First, we are going to use the setter method by setting the username public void set user name, string username. Type the username in the username field. Type came from the base page. Username is the parameter, and username field is the property variable. That's all we type for the username. Finish, done deal. Same with password. We write public void set password, string password. Type password in the password field. Next is the transition method. Public products page. Click log in button. Do you see why it's called a transition method? We are going to set the username, set the password, and click the login button. Then the login page transitions to the products page. We click login button. Return new products page. Pass in the driver. In this scenario, we return the page we transitioned to and not use the keyword void, but we use products page. An error shows up because we have a constructor that's needed in the products page. So we go to products page to extend our base page. If I can type it right, the constructor is public products page, web driver, super driver. Save, go back to the login page, and now the error goes away. Let's create a convenience method so our test has an opportunity to call one method for logging into the application. We're going to set the username, set the password, and click the login button. This method will be public products page, login with string username, string password, set username, set password, return, click login button. Someone may wonder, why do we have an individual method for set username, set password, and click login button, plus a convenience method? That convenience method and the three individual methods defeats the purpose of code duplication. You are right, but this is an exception. It's good to have an individual method because your test may have a negative text. For example, you might want to enter a username without a password. Click the login button, then confirm the application returns an error message. Let's add a getter method for the error message. Public string get error message. return, find, error message, dot get text. We have a string as a return type because the method getText returns a string. We are finished with the page object for login page. Now let's create a page object for the products page. I almost forgot to put in username, password. Go back to Swag Labs and inspect products label. Class is product label. Also inspect the backpack title. And we are going to use the ID, item 4 title link. Click the backpack, then inspect the add to cart button. Let's test this class value using CSS selector and write .btn underscore inventory. Bingo. Okay, we got our values. Let's go to the products page class. We already have our constructor. So let's add those 3 properties and their values. Private by product label equals by dot class name product label underscore label. Private by backpack equals by dot ID. I think the value is item underscore 4 underscore title underscore link. Private by add to cart button equal by dot class name btn underscore inventory. I keep spelling that word wrong. There it is. The first method is to check whether products label is displayed. So we write public boolean is product label displayed. Return is displayed. Locator is product label. Next is add backpack. Public add backpack. First, we want to find the backpack. Then click the backpack. After clicking the backpack, we click the add to cart button. We're going to also get the button name after adding the backpack to the cart. So we write public string get button name. Return find add to cart button. Get the text. I have a quote from Simon Stewart, the creator of Selenium WebDriver. It says, if you have WebDriver APIs in your test methods, you are doing it wrong. The WebDriver API commands are methods like click, clear, get text, and is displayed. These commands belong in our page object class and not in our test scripts. However, when it comes to assertions, I prefer to include them in my test scripts. There is not a rule that says assertions belong in our page object class or test scripts, but I think it's best to keep them even-handed, neutral. Here's the difference. In our page object, the assertion will have one outcome, either pass or fail. But in our test script, the assertion has balance, so we can use it for a negative test and a positive test. I have another quote. You probably noticed I did not speak about Page Factory. That's because Simon Stewart, who is also the creator of Page Factory, said Page Factory is not his best work. In a different message, he said the community took the wrong impression with Page Factory. If you want to watch the conference, Selenium, from 2017, he also said some more things about Page Factory. Next, we're going to create a base test, then execute our test using the page object model, and I'll see you in the next session. We create a test using the page object model by starting with the base test. One of the reasons for creating a base test is to set up WebDriver and to tear down WebDriver. Here's the base test and 3 test scripts. 2 of the test scripts are for the login functionality, and 1 test script is for the products functionality. For the base test, the variables are private, web, driver, and the URL is private, final string application under test, AUT_URL. The value is https://www.saucedemo.com. Some fields in our page object model may include final and may not include final. It depends on how you want to create your design pattern. Writing final is a way of making sure the value does not change. In this case, the value for AUT_URL cannot be changed. Let's start with the annotations for test_ng. At, before, class. Public, void, set up. We can use system.setProperty to set the arguments for WebDriver and a path to the executable file. However, I am going to write WebDriver manager dot Chrome driver dot setup. You can watch video 142 if you want more info about WebDriver. It's a library for automating the management of our drivers. Initialize the driver by writing driver equals new Chrome driver. Maximize the window by writing driver.manage.window.maximize. Load our application by writing driver.get AUT_URL. After loading the application, let's implement a way for our 3 test scripts to access the login page. Protected, login page, login page. I marked the field protected so each test script has access to the login page. After inheriting the base test, create an instance by writing login page equal new login page. Pass in the driver. Next is the annotation for after class. This configuration will tear down our test automatically after executing the test script. After class, public, void, tear down, driver.quit. We can write more in this base test, but that's all I'm going to write for now. The benefit of having a base test is to avoid setting up and tearing down every test. Now, let's move on to creating our login test. For the logged out user test, we inherit the base test by writing extends base test. The annotation is at test, public void test, locked out user gets error message. Now we write the logic for testing the locked out user. From the login page, we set the username to locked underscore out underscore user. Also, the login page will set the password to secret underscore sauce. Then click the button on the login page. Do you see how the IntelliSense shows the method click login button and products page? This lets us know that calling click login button has a transition, which returns the products page. The application makes a transition by changing from the login page to the products page. Therefore, we assign click login button to products page. Products page. Thankfully, we did not add a failed assertion to our page object class. In this test script, we expect an error because the user is locked out and we want the test to pass. Go to the application. The username, locked out user, password, secret sauce. And we see the message contains epic sad face. Go back to our test script and write assert true. Login page, get error message. Make sure the message contains epic sad face. Let's run. We see the test pass. Next is the test a user can log into the application, then verify the product's label is displayed. You see, I have each test in separate classes, but they can easily be in the same class. Either way is okay. On a project, I would group all tests related to the locked out user in one class and all tests related to a standard user in a different class, because we may have more than one test for each user type. First, we extend base test. Annotation, at test. Public void test standard user can log in. This time, let's use the convenience method on the login page. We will log in with standard underscore user, password, secret underscore sauce. Then transition to the products page. Products page. Now verify the product's label is displayed. Assert true. On the products page, is product label displayed? Let's run. The test passed. Let's create one more test really quick for the products page. go to the test backpack class, and it also extends base test. At test, public void test add backpack. On the login page, we log in with username standard_user, password secret_sauce, then assign to the products page. At this point, our test is on the products page, and the test will add backpack. After adding the backpack, we're going to verify the button name for add to cart changes to remove. So we write assert equals products page, get button name. We expect the name to be remove in all caps. This time, let's run all 3 tests. At the same time. Test add backpack passed. Test lockdown user also passed. We saw it pass already. And test standard user passed. We see all 3 tests were a success. That's it for creating a base test and creating 3 test scripts using the page object model. If you liked the video, consider subscribing to my YouTube channel, connect with me on LinkedIn.
Books available in paperback, ebook, and PDF. Programming books for Java. Here's the Selenium automation book. And TestNG. Subscribe to get notification of future videos. Don't forget to like, comment, and share.